Hi, everyone, and welcome to the latest Slooh Clubhouse clip. I'm Eric Edelman, the producer here at Slooh, broadcasting to you live from a very rainy Smoky Hollow Studios in Washington Depot, Slooh HQ. But today we are again going over to the Canary Islands like we did for a couple shows yesterday, where it might be a little humid there, but we're optimistic on getting some very interesting images of a very strange star. Today we're going to be talking about Nasty, also known as NAST1, nicknamed Nasty by the astronomers who've been studying it, because this star really has a lot of things about it that you wouldn't normally expect when you were looking at a star of this caliber, of this type. And so we're going to talk a little bit about what makes this sort of star abnormal and what the normal star would be in this sort of situation, and what we can really learn from these things that really we're going to show some great Hubble imagery of what the Hubble telescope has been staring at, what it has been learning about, and what we can really sort of discern from this about stellar evolution and another interesting sort of part of our universe. And here to accompany me and to really give us some great knowledge about this subject is a Slooh astronomer Bob Berman, who I've been talking to before the show, and there's a lot of interesting stuff to be heard today. Thank you for joining me here, Bob.
It's a pleasure as always. We went from the rather ordinary, the moon, although it's extraordinary to us because of the detail, to the truly esoteric tonight. So we're really making a jump from one night to the other, almost on opposite ends of the astronomy spectrum.
It's really pretty true. I don't think I can consider much commonality between the crazy activity that's going on in this star system that we're going to be talking about tonight, and our rather quiescent at the moment moon. So that's really, I think, a great place to start, though. Like, what is this system that we're going to be talking about today? The word Wolfray is probably going to be thrown around a lot. Like, what is that exactly?
Well, Wolf-Rayet stars are the almost the extreme of stars. They are the massive blue, hottest stars that are so hot that they don't even give off an ordinary spectrum. When we talk about spectra, I know some of the people in our clubhouse and members of the Slooh membership know something about it, some don't. But when you hit sunlight striking a prism, you get all the colors of the rainbow. That tells us what the sunlight is made of. Well, if you do that same thing with a Wolf-Rayet star, you don't get the ordinary colors. You get a very strange spectrum. And they've been strange ever since the mid 19th century when we first realized about these stars. But this is kind of the stranger of the strange ones. And those of you know a little astronomy know that spectral sequence. Ever take Astronomy 101 and learned, oh, be a fine girl, kiss me? Well, some of us learned it with a W in front. Wow, oh, be a fine girl, or be a fine guy, whatever you prefer. The mnemonic that astronomers learn for the spectral type. The reason the W is all the way over at the end is because these are the most furious, fiercest, hottest, most massive types of stars. And this one, even in that odd company, strange, unique company, this one's strange, even as a Wolfrayet star. It's odd.
And sort of as a point of comparison, like how would you compare, say, our sun to a Wolf-Rayet star? Like how much bigger or how much more furious would a Wolf-Rayet star be than our sun?
Let's put it this way: our sun goes through its lifetime in maybe 11 billion years. It's about halfway finished with that. Every second, our sun gives off 96 billion hydrogen bombs worth of energy, 96 billion per second. Now, picture something that's dozens, if not hundreds of times fiercer, with temperatures instead of a surface temperature of 11,000 degrees Fahrenheit, the way our sun has, now picture 35, 40, 45,000 degrees. And with that kind of temperature, you get a blue color. So these are always blue stars. And we used to think they always represented a young stage of stellar evolution of very, very massive stars. They're going to go through their lifetime very quickly. But we found other Wolf-Rayet stars that are ordinary sun type masses that have collapsed with a planetary nebula. You know, sometimes it's Slooh. We look at the Ring Nebula or the Helix Nebula, other planetary nebulae. Well, the central star collapses to become a blue, very hot star, not even particularly massive, just blue. And these too can give off that weird spectrum of ionized helium lines, things you don't normally see in a star. So the Wolf Rayet umbrella category embraces lots of stars that all have in common that they're massive, extremely hot, have an extremely strange spectrum of emission lines rather than those little dark lines that we see across the colors of the rainbow. Um, but we don't really think of them primarily as being binary stars, two star systems. But this one is, and it may be giving us a clue about what's going on with some of these Wolf-Rayet stars.
It's there's so much to be seeing. In particular, this is an artist rendition that we're looking at right now of what the system looks like, and it gives us little clues and little hints as to what is fascinating astronomers about this. The really sort of the bright ball that you see that sort of has a triangle sort of heading off it. That's sort of matter being flung off the star. That's the one that we're talking about right now. That's nasty. And nasty, as sort of astronomers are seeing, is making a bit of a mess, being true to its namesake. And you see this huge gaseous disk around it. And could you maybe talk a little bit about why that's so unique?
Yeah, because we don't usually see that. You're expecting a very massive star. Sometimes you get a lobe or a twin lobe of material, like in Eta Carini, but not a disk. Now, a disk, this is a flat pancake about 2 trillion miles across, huge
Wow.
pancake, much larger than the solar system. And the only thing that we can be thinking of that could cause it is a companion star that's pulling material, ripping material away, exposing this poor star's core. It's already massive. It's already got a huge wind of material ripping away from it. Our sun throws off about 6 atoms in each sugar cubed size bit of space. The solar wind that was discovered in the 1950s by Gene Parker. But in these stars, it's so much fiercer that it loses a lot of mass in a short amount of time. So we thought that's what's going on with these. That's why the stars are evolving. They're just giving off a very fast stellar wind. Not in this case. The star is buried within a disk, a flat pancake disk. So apparently there's another star, a second star, binary star, pulling off material. And that's making us think, well, maybe that explains a lot about this type of Wolf-Rayet star that we never knew before. Maybe binary stars are more involved in the process than we ever thought. The only reason we're calling it nasty, really, is because the two discoverers, the first couple of letters of their names, Jason NASA and Charles Stevenson. So Na and St made for St, and then it's the first star in their catalog, discovered way back in 1963. So Nasty is just an abbreviation of their names.
And here is the first live image coming in from the Slooh telescopes of Nasty as we're seeing it tonight. And so there's a lot of stars in this field. I'll help you out, point it out a bit. This is what we're looking at here, where there's two stars looking real close together. There's a small star in between. We're looking at the right one right there.
Yeah,
There
and
is
you
Nasty.
wouldn't know it looking at that, of course, that anything odd was going on. That's often the case. Many of our Slooh members love to look at the Crab Nebula, not now because it's lost in the glare of the sun, but at the appropriate season, um, the central star, a neutron star, spinning crazily at 30 times a second, that's in the heart of the Crab Nebula, and there's another star right next to it. So many people wonder, well, which one is it? So here we've got the same situation where one is this extraordinary, nasty one star, this Wolfray star, this incredibly massive, luminous blue star that's shedding material at a violent rate. Something strange, Eric, is going to happen to it when a star is this massive and changing this rapidly. We're talking about a lifespan of maybe a few 100,000 years, as opposed to our sun's lifespan of maybe 10 billion years. We're about halfway finished with it now. So, what will happen as this material from one star is ripped off and settles onto another star? First of all, massive stars can blow up into a supernova. Our sun can never do that. Secondly, maybe that won't happen. Maybe just that second star will attract so much material that it will evolve and just go through fluctuations. Or you could get violent outbursts the way Eta Carinae does famously, where you get novae, not supernovae, just novae, bursts of material that comes out. So we don't know what's going to happen. But when it comes to massive stars like this, something's going to happen, and you don't want to be in the neighborhood when it does happen because it's always going to be violent.
Absolutely, and I mean that brings up a good point. Like how far away is this thing that we're looking at? I mean, we see it here, the Slooh telescopes, as this really tiny, almost insignificant dot. But we see it with the Hubble Space Telescope. We have this image that that was came out just very recently. We see the disk there.
Yeah.
Uh, but where is it? Do we know at this point?
Yes, yes. Well, it's in the constellation of Aquila, the eagle, and that's part of the Great Summer Triangle out these nights. As for its distance, it's a little bit far to be measured with the Hipparchus astrometric satellite that we use to measure distances. So we can just estimate its distance as somewhere between 3,000 and 9,000 light years. By comparison, the farthest stars of the night sky that we see naked eye are typically about 3,000. Most stars are, let's say the Big Dipper stars are about 100, Vega's 25, Arcturus is 36. A really distant one like Deneb is 1,500 light years. So when you're talking about 3,000, you're talking about farther than most of the naked eye stars that we'll see in the night sky, and yet not horribly far, considering that our galaxy is 100,000 light years from side to side, and this is part of our galaxy. It's certainly not in even the neighboring galaxies like the Magellanic Clouds, let alone the Andromeda Galaxy at 2.5 million light years. So whether it's close or far depends on your perspective, but it's not terribly far for an object with this kind of violence and this kind of interest.
Yeah, I mean, just to cover all our bases, what are your thoughts in terms of if there was a really violent um, reaction that happened with the mass? If there was some nova, some supernova, something that happened, would we
Well,
have to be
we'd
concerned right
love
away?
it. We would love it, Eric, because a supernova is something we have not seen in our own galaxy since 1604. We actually had two of them in a single lifetime in 1578 and 1604. And then before that, it was uh, back in the 12th century that we had one. So typically, you get a supernova, one per galaxy per century. And we're way overdue now. So we're talking about 400 years since we've had a supernova in our galaxy. The closest one we've seen in our lifetimes has been supernova 1987A, and that was in the Large Magellanic Cloud. And you're talking about 750,000 light years away from us. So personally, Would we want to see a supernova just 3,000 light years away? Heck yes. Lighting up the sky brighter than Venus, making us have temporarily a blue sky at night. That'd be kind of cool. We get a little bit of radiation from it, not enough to sterilize life on Earth at that distance. But how about having a blue sky at night? That would be kind of cool for a while. They
That,
typically last for a year, so it wouldn't be the end of the world. It wouldn't be like we'd lose all of our beloved stars and constellations forever, just for a while.
I think the question that is on the top of everybody's minds right now as we're hearing this, as there's the possibility that the sky could turn blue, that there could be a supernova so near to us. What would the effect be on noctilucent clouds if that were to happen?
That's funny. Well, we'd get a bigger radiation flux. We get some radiation from it. We get a bunch of neutrinos, which don't help you and don't hurt you. They don't do anything for you, but there'd be an influx of cosmic rays, the likes of which we haven't seen on Earth for a long time. And to have a sudden star that bright in Aquila the Eagle. Right now we have the star Altair. Those of you who know a little astronomy, the great summer triangle made of Deneb and Vega and Altair. So this is in that same constellation, same neck of the cosmic woods, not far from the plane of the Milky Way. And there it is through the Slooh telescope. So easy for us to see, but very difficult to peer through all of the gas and dust and actually see what's going on. Even the Hubble Space Telescope, by the way, cannot do that, which is why the best we could do is show you an artist's picture, an artist's version of what that really looks like. The best which is what we're looking at right now. So we can't see it clearly. It's kind of a fuzzy blob, even though it was discovered way back in 1963. Nasty. And I guess the way you would try to make that name, again from NASA and Stevenson, the two discoverers, that's a combination of their two names, is that because this star is losing its outer shell and it's pouring into space like a pancake, it's sort of a nasty thing happening to it, that the star is being ripped apart by the presence of a companion star. And that's not that uncommon to see that kind of thing. What's uncommon is for it to happen to a star that is so massive and blue and hot and ferocious and already losing its mass just due to the ferocity of the nuclear fusion process happening in its core. Very little hydrogen that we see in the star, and that's usually what we see. We just showed some people the spectrum of Vega the other night. There's almost a pure hydrogen spectrum. This is the opposite. Very little hydrogen. Instead, we see weird things we don't. We're stripping away the outside of the star and seeing the kind of naked core inside.
It's so dramatic, really, what's going on. And it's been so much fun to hear what you've had to say about this, Bob. Like, thank you for bringing this star to light for us, and the mysteries behind it. It's always fun to hear about sort of a new and sort of exotic topic in astronomy here. And really, you can do a lot of interesting science for yourself in the clubhouse. Slooh members, you're welcome to it. As people that can use the telescopes, the citizens astronomers, you can look on a list of different objects for a night, and you can pick one in terms of a reservation. And you can also do something called, a coordinate mission, where you can take particular coordinates in the night sky and look at a very, very particular point in it. If there's something that is maybe off the beaten path that you want to look at, that's an option for you. That's available for you. There's lots of stuff to see, and of course, we're here to help with that, to facilitate that. If there's ever something that you find that's really interesting that you'd like to hear more about, let us know. In the live shows area, we're always looking for new topics to cover, because we want to always be a source of information for you and entertainment about the universe. And so please do send us what you'd like to see in the sky, and also maybe questions you have about upcoming shows that we could, of course, answer live for you. We're here to make a conversation about these things. Uh, but as we're sort of ending our exotic topic for tonight, Bob, are any last sort of thoughts about Wolf-Rayet stars, or about the evolution of our understanding of these systems?
Well, it is, yes, and it's fascinating that we have so many in a single category. You know, as like many sciences, we tend to put things in smaller and smaller boxes. But here's a whole category of violent blue, massive, super hot stars, and this being one of the strangest in that category. So that's great to see. And as I said at the outset, and I'll repeat it now, it's great that we go from the ordinary, although beautiful, the moon, to something as odd as this. And we were just looking at Saturn a few nights ago, too, here, now at its best in 8 years. So I know Slooh members are focusing on that as well. So it's a whole universe out there. It's great. I mean, we'll never run out of topics, will we?
Yeah, it's great. It's great to be here at Slooh because yeah, there's never going to be an end. We're always going to be exploring something more. And so yeah, thank you so much for joining me here again on the show, Bob. And thank you, Slooh viewers, for watching as you have. And it's been a lot of fun these last couple days to just hit you with show after show. We're going to be doing more of that. As the days go on here, you can look forward to next week. We're going to be looking a little bit at Pluto, and there's a very interesting event that's coming up in terms of Pluto, the New Horizons flyby, where we're going to just see Pluto in such fantastic detail that we haven't seen before. And so, leading up to that, we're going to have another Clubhouse clip, sort of talking a little bit about what we've seen so far and what we still have to expect. As well as that, there's going to be a lot of fun planetary shows coming up. There's going to be an occultation show, or as we'd like to call them here at Slooh, a photobombing show, and some different fun Jupiter moon events. So stay tuned for that. There's so much to come, and we will be back before you know it. But for now, this has been Eric and Bob for Slooh. Thanks for tuning in.
Good, good night.